Hello, today we are going to debug Bash shell scripts. So born again shell source code using Visual Studio Code. We're going to use the Visual Studio extension by rogalmic, which is rogalmic.bash-debug, which uses bash-db, which is in a family of debuggers similar to GDB. For various programming languages and shells. There's one for Python 3 and 2, one for Bash, another for Z shell, Corn shell, Perl, Node.js, but also for Make, GNU Make. The developer is named Rocky Bernstein. And this is the official web page for BashDB, bashdb.sourceforge.net. Okay, I have this Git repository. So this is the directory where I have git clone the Git repository xdg-utils. Let's open a fresh Visual Studio Code editor in here. Don't show anything. Close. And let's look a bit. Collapse all of the source code. And we're looking for the executable xdg-open, which is in the scripts directory. This one. I have put some breakpoints. And now let's look at the extensions. There's no extensions in this Visual Studio Code. It's a clean new profile. Let's search the extension for Bash. The most popular one is the one that we're looking after, which is rogalmic 834k. Downloads. Let's install it. Okay. And it behaves similarly to other Visual Studio Code extensions that provide a debugger. You need to create a launch.json file. We're using the debugger bash-debug. We're using the simplest configuration possible. There's other possibilities in here. We're debugging the current file, but we want to run a command line like, see this, so scripts /xdg open and then a website. And the web browser opens correctly. Okay, so this is the command line that we want to actually run. xdg open will be the program, so the file, we need to select that file before starting the debugger. And then we need command line arguments, which is this part, just one URL. Control V, Control S. So let's make sure we've opened xdg open, executable. And now we're starting the debugger. If we have the breakpoint. So we've put a breakpoint at the first line that's not defining a function, which is 425. Let's start the debugger. Okay, so it stopped at the first line it could. And we can see that check common commands is a function. This is, we can evaluate $@ either by hovering on top of it or going right click and evaluating debug console. Let's see if we can step into F11. We can. It stepped into the bash function check common commands. Why do we know that we are using bash? Because it's this script requires any born compatible shell, so Unix compatible shell. Bash is such one, and Bash will be able to interpret this script file correctly, because Bash is a superset of the born style POSIX style shell. Okay, let's see what it does. So a while loop. This is the so $ hash mark is the number of command line parameters. There's one, and it's greater than 0. And we're walking through all of the arguments, the command line parameters. So $1 is the first remaining parameter, and then we're shifting, and next time $1 will be nothing because we only have one command line parameter. We can see in the Visual Studio Code Run and Debug tool window the exit status of the previous command. So the previous command was shift, which returned success, which is 0. Okay, now we're in a alternative structure case. It's not this parameter is unknown, so it's not the parameter minus help minus manual minus version or minus. So it's unknown. Next up, I don't really like to scroll left and right. Let's configure Visual Studio Code such that I do not need to scroll left and right. So that's File, Preferences, Settings, and Wrap. Word wrap should be on. Okay. Now it's evaluating the environment variable xdg utils debug level. Let's inspect its value. By hovering on top of it, we do not get anything interesting. Let's evaluate in the debug console. It says that it's empty. So it has run -z, so square parentheses, which is probably test, and then -z, and then this thing, exit status 0, which means success, which means it's going to, because this is successful, and means that if the left operand is successful, then the right operand will be run. So it's going to run unset xdg utils debug level. And that's exactly what it does. It did. We can see the command line that it has run previously, unset xdg debug utils debug level with exit status 0, which is again success. Then an alternative structure if, which says that if this thing is greater than 1, is less than 1, we cannot evaluate it by hovering on top of it. Let's evaluate it in the debug console. It's empty. So all of this test has returned successful. This part without the semicolon. So it entered the then branch of the if alternative structure. Okay, this is a pipe, which means, let's exactly see how it looks like. So F10 says that the left operand has returned exit status 0, which is success. Then it did not need to call the function, the bash function, the shell function exit failure syntax. Okay, URL is empty. Okay, then it goes through the parameters, the command line parameters. Greater than 0. There's two parameter. There's just one parameter. Parameter count. So $1 is the URL to google.com. $, hash mark is 1. Then it goes shift. Next time $1 will be nothing. And it's looking for anything. Okay, executes the alternative structure if with this block, which says that minus n URL. Okay, so I found out what square parenthesis minus n is. So square parenthesis is test, which would be an executable found in the path or a shell built-in. And there's a man page for test. This minus n means the length of the string is not 0. And the local variable URL is indeed an empty string because it's declared in here. In here it's checked. It's empty. And then it's going to be assigned the value https://google.com. Okay, there's no more command line parameters. Okay, then it's using test minus z, which means that the length of the string is 0, which is false. So it's not going to exit with error message. In here, it's detecting the Linux style desktop environment, such as KDE Plasma or GNOME Shell. Let's actually enter this function call. XDG current desktop is KDE. I'm using KDE Plasma 5, and the Linux operating system that I'm running this on is Kubuntu 23.10. Okay, so XDG current desktop is KDE. It's using a case alternative structure. It goes to the KDE branch, sets the local variable d to be KDE. The DE and local variable is not is a string but not 0 length. Not 0 length, not 0 length. And then it's comparing if it's GNOME. and it's not. So let's see this thing evaluated. It's xkd, whereas this thing evaluated, it's xgnome. So it will not enter the if, the then branch of the if. Okay, then it computes if we're inside of a Flatpak application. We're not. D is still not empty. Debug2, let's see what this thing does, F11. XDG utils debug level, what's the value? It's empty. So it returns success, does not print anything using echo. Okay. Sanitize the browser. What is that? It's empty. Okay. And then after all of the pre-computations have been done, the correct desktop environment has been selected, which is KDE. It actually goes to the KDE specific backend of XDG Open, which is this Open KDE Bash function, F11, to step into. There's 3 possible versions for KDE Plasma, 4, 5, and 6. 5 is the current one. 6 is going to be released in a couple of days. In case KDE session version, we're at version 5. Okay, so we can evaluate just the environment variable, the value of $, and curly brackets, and the environment variable. Or we can also use the double quotes to surround the bash expression. Okay. And now it's going to call the function openkd5 with the parameter the URL. So F11. It worked. So I'm guessing KD open is an executable that exists on in the path, because stepping into did nothing. There's no bash function KD open 5. Let's determine that that's the case. So KD minus open, and here it is. /usr/bin /kd minus open 5. Okay. We can see that the exit status is 0 success. In case of success, there's one parameter. And it exits successfully. And that's it. Okay. So again, we have used the work of Rocky Bernstein with the many debuggers that Rocky maintains for Python 2, 3, Bash, Z Shell, Corn Shell, Perl, Node.js, and GNU Make. This time the one for GNU Bash. You can run it from the command line, or you can use a front end. So it behaves similarly to the GNU Debugger GDB. So you can use the front end, for instance, this antiquated piece of software, which is DDD, or you can use the plugin for Visual Studio Code, and there's also a plugin for the JetBrains IDEs. Very easy to use. There's additional documentation in the extension page. You can look at these GIFs for additional information on how to set up the debugger. And can also look at the Visual Studio Marketplace page and click on the GIFs to make them bigger. Okay, so in add configuration, there's multiple possibilities for bash debug. You usually want to hard code the script name, not use $sign file, not debug the current bash file. So very useful. I could do anything that I wanted. I can evaluate everything in the debug console. Some of the identifiers can be evaluated by hovering on top of them. You can step into bash functions. So step over, step into, work OK. There's also the call stack. Let's look at that. You should ignore the first elements in the call stack because these happen inside of the bash-db. You can see them bash-db in here and bash-db in here. But then the third entry in the call stack is, in my case, my own code that I want to debug. Let's go step into. And now we have 4 elements in the core stack. Inside of the function check common commands, inside of xdg open, top level. Let's see if step out works. This button, step out shift F11, works okay. Very handy in the variables tool window, local and $sign question mark, which always shows the exit status of the previous command that has been run, and also importantly the command that has been run. Because for instance, in situations where you have multiple commands in the same line, these multiple commands will be split, executed one by one. You can see which one was executed and its exit status. So in this case, we have the binary operand and, which has a left hand operator and a the binary operator and two operands, the left hand side one and the right one. Okay, we're going to step over F10, and now it executes the right operand. I couldn't ask for more from a Bash debugger inside Visual Studio Code. There's all the tools that I need to debug even the hairiest Bash issues using Visual Studio Code. Thank you.